Consider dy dx is equal to x minus 2xy. Y of 0 is equal to 1. Remember that means that y is equal to 1 when x is equal to 0. So, we'll come back to that. Without solving the equation, find the first three non-zero terms of the Maclaurin polynomial expansion for y. Well, okay. So dy dx is equal to x take away 2xy. So dy dx evaluated when x is equal to 0, well, that's going to be 0, take away 2 times 0 times y, so that's going to be 0. Now we can differentiate straight from here, d2y dx squared. That is going to be 1, and then don't forget this is a product, so that's going to give us minus 2y minus 2x dy dx. So if we do d2y dx squared when x equals 0, that is going to give us 1. Now we know that y is 1 when x is 0, so take away 2, and then this is going to be 0 because of the x being 0 here. So plus 0, that's equal to negative 1. And then we can do d3y dx cubed. So that would give us, well, the 1 will differentiate to 0. We'll get minus 2 dy dx. And then we need to treat this bit as if it is a product. And if we do that, we get negative 2 dy dx. Take away 2x d2y dx squared. And we want to evaluate that when x is equal to 0. So, well, we know that dy dx was 0 from up here. So those first two terms are going to give us 0. And then if x is 0, well, it's just all going to be 0, isn't it? So 0. And then we want d4y dx4. So that would be, let's put those two together, that's negative 4 dy dx, so that's going to be negative 4 d2y dx squared. And then we'll have, treating this one here as if it is a product, we've got minus 2 d2y dx squared, take away 2x d3y dx cubed. And so if we evaluate that when x equals 0, well, d2y dx squared was negative 1, so those two things are going to give me 6, and then this is going to give me 0, so that is equal to 6. And so, together with this, we can say that y is equal to 1, and the dy dx was 0, so the next term is the minus 1 as the coefficient, so that's going to be minus x squared over 2 factorial, which is 2, and then the d3 term would be 0, so there'll be no x cubed term, and then the next one is the 6, so that would give us 6x to the 4 over 4 factorial, and tidying that up is going to be 1 take away x squared on 2 plus x to the 4 on 4. We then want to solve the equation exactly to find the particular solution. Okay, so we have dy dx plus 2xy is equal to x. The integrating factor is going to be e to the integral of 2x dx, which is e to the x squared. So we get e to the x squared dy dx plus 2x e to the x squared y is equal to x e to the x squared. On the left-hand side, we can see is what you get if you differentiate y e to the x squared. So if we integrate both sides, y e to the x squared is going to be a half the integral of 2x e to the x squared. Note what I've done here, so that we've got this being the exact differential of that. And so we can say y e to the x squared, y times e to the x squared there, is equal to e to the x squared on 2 plus a constant. Dividing everything by e to the x squared would give me y is equal to a half plus c e to the negative x squared. And then we have y equals 1 when x equals 0. And so if we put that in there, we would find that we would get 1 equals a half plus c. So c equals a half, and therefore y is equal to a half plus a half e to the negative x squared, and we're done.